Hello everyone, this is a summary of chapter number 3 from your textbook. The title of chapter 3 is still on descriptive statistic. However, the content of chapter 3 is actually go beyond statistic a lot. In fact, the true content of chapter 3 is on the topic of data warehousing. Therefore, you will see a lot of this technical description about data warehousing in this particular chapter. As a business student, I believe that when you are reading this particular chapter, you will encounter a lot of these technical issues that you may not be able to understand fully, which is fine. My goal and the goal of this course is to make you familiar with some of the terminology that we use in this particular field. We will start by defining the term business analysis or business intelligence in the world of analysis. Based on our classification scheme described from chapter 1, business analytics is classified into three different types: descriptive, predictive, and prescriptive. The most easy way to understand business intelligence is that business intelligence is the descriptive analysis or descriptive analytic in the world of business analytics. In my summary, you probably hear me saying the terminology analytics and analysis sort of like alternatively. Actually, these two terms does not have that much differences. It's the official name, of course, is analytics, but it's basically talking about the basic concept of in business analytics we call drill down analysis, or something we call the slice and dice analysis. The slice and dice analysis corresponding to another terminology we learned in a previous chapter as well as later in this chapter called OLAP or online analytical process is referring to the same thing. We are trying to look at the data from many different perspectives. And I also mentioned in previous summary that OLAP is a analysis method very similar to the pivot chart in Excel, but it gives the tools, the technology tool, more powerful data processing capability and visualization capability. So putting this data processing and visualization capability on the pivot chart analysis, the OLAP or online analytical process become the anchor point for business intelligence or business analytics. Traditionally, when I say traditionally, is in the scale of technology world. So tradition means that in the past about 20 years or so, the OLAP analysis or the OLAP technology depend heavily on a data processing technology called data warehouse. Data warehouse is one type of relational database because most of the data warehouse is built on top of the relational database engine. And for those of you who are not so sure about what does that mean by relational database, it's just referring to the most popular database that we are using in today's commercial world. But in addition to use this database engine, the data warehouse also has other features or special purposes. This particular slide gives you a definition of it. There are three highlighted or bolded terminology to describe data warehouse: integrated, subject-oriented, and non-volatile. The general idea of data warehouse is that when we are trying to do big data analysis or try to study some of the terminology, actually, I was just learning a terminology called dark data. Without explaining what dark data is, basically those are the data and information hidden in the piles and tons of data that has been collected in organizational database in different places. So the goal of organizational or enterprise-wide data analysis is try to integrate all the available data from different corner of the organization, sometimes even go beyond the organization, go externally to collect market information, collect customer information, and put together with operational inventory, everything together into one database. Then this one database can be used for further analysis, and that database is something what we call as a data warehouse. So it is a concept of integrating different type of databases. And the job of integrating all these databases is complex and difficult because there are a lot of conflict and inconsistency among different databases. So the whole idea of building this data source for analyzing organization data become a special technical field in the technology world. From the historical timeline of data warehousing and business intelligence, if you look hard enough in this particular slide, you will find that the term data warehouse has become popular in the 1990s. It's actually coming out of late 1990s and become more popular in the early 2000s. But the popularity of data warehouse start to fade away in after 2010 or so. The reason is because the idea of big data is coming in, and we have a lot of these data coming in the pace that is much faster than the traditional database, including multimedia, including many of those non-structured, non-relational database that cannot be put into data warehouse. So today we are actually go beyond data warehouse already in terms of business intelligence. But the core in most of the commercial operation, data warehouse is still a backbone of, especially internally for organization to collect, processing, and analyze their data. Our focus in learning of this particular chapter is understanding or at least familiar yourself with the terminology. And some of terminology you can understand that from the intuitive sort of like a common sense understanding. For example, we have this concept of data warehouse. So you can imagine in our operational term, warehouse is a place you have, it's a huge place. You put a lot of data in there. But we also have this terminology called mart, data mart. And mart compared to mart is like supermarket, and compared to data warehouse, it's a relatively smaller. But we also will see the terminology called data store. So compared to the idea of warehouse, data mart, data store, you know that it's a hierarchical sort of relationship among these terminology. Data warehouse is the most integrated, centralized, big place for storing and processing data. Data mart is in a medium scale. Maybe you don't need that much data, so you kind of using a smaller operation to process the data. Data store is even more in terms of scale, smaller operation. So you probably do special project in data analysis in data store. So familiar yourself with your supply chain common sense to understand the terminology will be good enough. If you try to read the textbook in much detail and try to really be picky on the definition, that will be hard. But for the exam purpose, just get yourself familiar from the quiz selection. Those general understanding will help you get a sense of where they are and how and why we define these terms. Now, on this particular slide, you see that there are four terminology. One is called Operational Data Store, ODS. You can compare this to another terminology you probably have learned in MI's classes called Transaction Processing System, or TP, TPS, transaction processing system. Those are referring to similar thing. And you have operational mart. So that is a middle tier data warehouse we were talking about. And you have a larger scale enterprise-wide data mart. Now, one terminology that is worth a little bit special understanding is this terminology called metadata. And in the general or common sense understanding, I would say that treating this terminology as something, sometimes we call this as a data dictionary. So metadata is basically a dictionary of your data. It's a definition of your data. Say, for example, if you have a table in Excel spreadsheet, you label this particular spreadsheet as income, right? So what does that mean by income table? And you further describe that the income is coming from the operational income, not coming from the sale of your asset. Then once you understand the meaning of that income, then that definition of the terminology is something we call as metadata. So metadata is data dictionary in the technology world. Now, understanding metadata is important in the process to build a data warehouse because when we try to talk about the concept of integrating data from different sources, you want to make sure that the income I collect from one source is exactly matched to the other income you say that you are taking from another sources. Without the true understanding of the terminology used to define the data you are collecting, that will cause confusion. Give you a small example. For example, if you have a column in the table has the label say a weight of a particular product. Um, so you have to further define what does weight mean, what unit of weight that particular column is using. Maybe in one data file, the weight is measured by kilogram, and in another data file, is measured in pounds. So if you try to combine data from these two sources, one in kilogram, the other in pound, that obviously has some problem, right? So you get the data quality problem. So once you have the definition of the each one individual data sources and the target integrated data store or data warehouse, then you will be able to convert the data in a more accurate sense. So the role of metadata is serving that particular purpose. So if you take my statement before this particular slide, then you probably understand that already now. Our goal in business intelligence and traditional business intelligence and data warehouse is basically taking data from the left-hand side of the different data sources and try to using the metadata to do some rearrangement, integrating the data together into a data warehouse, a large data warehouse, and then be split into a smaller data mart or data store. Then each individual and organization can use that smaller data sources. It is the whole process called data warehouse. So this is actually a process framework. And some people like to call this particular process or actually using a analogy of this particular process on this slide to describe something what we call as a data warehouse architecture. So later in this particular chapter, when you encounter the terminology architecture, it's basically describing now we have this job of taking different sources of data, put them together, and distribute to different user and the share stakeholder to use, and what technology we're going to be using. Different technology will determine the different type of architecture we will be talking about later in this particular chapter. And to repeat myself, there is a terminology here called ETL. It stands for extraction, transferring, and loading. It's a typical terminology we use to describe the process of taking data from, extracting data from different sources and uh, transferring or moving them to a new location, new databases, and load into an integrated, consistent target, and that process is the data warehousing, data processing preparation process. So now we get into the data warehouse architecture is talking about how this system, how this technology is built using different type of technology and design. So we have traditionally called a three-tier, uh, defining different machine as a to serve different role in the process of ETL and data warehousing, or two-tier, or sometimes even one-tier data warehouse operation. So graphically, you can see that the two-tier, three-tier is basically using different machine to perform different job in the whole process of data warehousing. And some of these terminology has been introduced in your introduction to MIS course. I will not elaborate too much. So if you keep reading, you will find that when we use the web technology, internet, as as a delivery tool for data warehouse report or analysis, you have a web-based architecture, and there are different arrangement of the technology put together. You can go through the process in different platform and machine, and result in various kind of architecture. So the detail is actually not that important, but you have to understand there are many different design of data warehouse process that can achieve the same thing. And each one of this design has its advantage or disadvantage. And sometimes the advantage become disadvantage. For example, one idea of the data warehouse is to centralize the data. But a lot of times, centralized data will slow down your operation because when you have a remote location want to use the data, then the data will be downloaded from the centralized machine, and that will be not very efficient. So sometimes the other direction will be distributed. So the data will be stored in a localized different region, and that creates another problem when you try to do a enterprise-wide analysis. Data have to be collected from each individual nodes on your distributed system. That creates the other side of the problem. So the architecture selection, how you put the data together, what technology to use, what communication you have in different machine is the topic discussed. Mainly, actually, your textbook spend quite a few pages to describe the architecture design. I, on the other hand, does not think that is very important from a business student's perspective. But it just familiar yourself with a different understanding will be good enough. And of course, the architectural discussion is always a hinge upon the ETL process. There are several slides and several pages describing the ETL process in much detail. You can take a look at the the picture and try to understand the process. That will be good enough. In the technology world, the two basic model of data warehouse architecture. One is centralized. You build a big centralized database. The other is distributed. You build a lot of smaller database and let them work together. And the integrated or federated system together try to achieve the data warehouse purpose. These two design concept has two different, well, you can call them founder or pioneers to start the design. And the Inman model that you see on this particular slide is this centralized idea, and the Kimball model is the distributed bottom-up sort of idea. So knowing these two persons' name probably will help you to have more like professional look conversation with technology people. So when people in the data warehouse hear you saying that, oh, you ask a question about is this the Inman model or is this the Kimball model, they will show different respect. Or on the other hand, if you are talking to technology or data warehouse professional, they when you use the term Kimball model, they do not understand. They are not knowledgeable enough in the data warehouse world. So the Inman model, top-down, centralized database. Kimball model, bottom-up, distributed database system for data warehouse design. That is a very good and simple way to understand the data warehouse terminology. In some detail of your textbook presenting comparing data warehouse, enterprise-wide data warehouse with the data mart. And as I mentioned earlier, data mart is like medium range, medium size operation. Data warehouse is what large, huge size operation. With that in mind, that the comparison table become meaningful. So there's no need to go into too much detail, but understand the difference in terms of scale, then you will get the idea. The other side of classical data warehousing terminology coming from also how do you design the data structure. So earlier we talked about the Inman model and Kimball model, talking about where you put the data in data warehouse solution. Now in here, we're looking at your database, how you design the database in data warehouse to achieve efficiency or performance goal. And we have two basic designs. One design is called the star schema design. The other is called the snowflake design. As you can probably see that the star is more or less like a centralized idea, and snowflake is more distributed compared to star, right? So that will help you to understand. So star schema is matching more with the Inman model, and the snowflake schema is matching more with the Kimball model. You know, one of the thing I'm using, one words that I'm using here, is called schema. And earlier we talked about the terminology called metadata, and I refer that or try to explain that using the term dictionary. As a matter of fact, the schema is relating to the data dictionary as well. So when the technology people talk about schema, they are talking about the definition or the dictionary, how you define that particular data structure, data meaning of the data. So schema can be understood that way. So you have this data structure defined in the look star-like design, what we call a design schema, and the database is designed in a snowflake like the structure is called snowflake schema. Now, if you want to dig further or actually want to engage in more discussion on this, and they probably require you to take additional MIS class. But for our understanding, you have to get to know three more additional terms to get to the level we have knowledgeable conversation with professional. The term is coming from the difference between dimension and measurement. So on this slide, you see there is a model called dimensional model. In the next slide, you will see there are three different measurement or presentation of data called dimensions, measures, and time. And these three terminology referring to the data type you are looking at. So usually when we are looking at dimension, in chapter 2, I use the different what's called the structured data. And in that structured data classification, we call categorical data type. Whenever you see a categorical data type, that is called dimension. Whenever you see a numerical data type, it's called the measure. And also there's a special numerical data type we call time. All three together, and you have the foundation of OLAP analysis. Now, why do I say this is the foundation of all lab analysis? Because measurement are usually the performance that you're trying to measure in organization. Sales and the efficiency, productivity, all these are measured because they are representing in number. And different division will be a categorical, there will be dimension. Different geographic location, there will be categorical, will be dimension. So you can analyze the annual sale measurement by region. That's dimension categorical. And so once you have that understanding, you can build different visualization, different chart. Bar chart, for example, you want to build your dimension into say horizontal axis in terms of categorical. Then you put your vertical as measurement. You have a bar chart, right? So that is the way we understand the data. So once you be able to perceive data in terms of dimension and measurement, you can present them in different way of report and presentation. So when later in our course, when we have chance, I will try to explain using an example to give you more sort of like understanding and general common sense toward these three terminology. So understanding the dimension is an important mm, foundation concept toward this thing we call OLAP, Online Analytical Processing. And your textbook compare OLAP, this term, with OLTP, Online Transaction Processing System. So one is actually for the day-to-day operation. So whenever you go to Walmart, you go buy something, and they collect data, what you buy, what credit card you use, and they probably even monitor your movement around the store. Those are the online transaction processing system. So the term is no longer that meaningful in today's environment because in our environment, almost everything is online. When they say online, it really means uh, real-time data collection. And so the second terminology called OLAP or online analytical processing is basically saying that we are doing the other way around. One is data processing and collection. The other is we are going to be doing real-time analysis, real-time report. So your sales report, your the predictions, all done in real time. So OLAP has that real-time meaning in our analytical world. And the operation of OLAP is doing these operations: slice and dice and drill down, drill up, roll up, and pivot. And we do have a technical tutorial that is target using the pivot table in spreadsheet to perform this type of operation. To further understand what does that mean by slice and dice, drill up, drill down, drill down, drill up, and roll up, and pivot is probably the best to understand using this picture. So basically, you are taking the big data set and try to get a summary of a smaller data set. So how do you get a smaller data set defining into different operation in OLAP? Slice, dice, roll up, and pivot. Since this particular textbook was written by a MIS professor, actually three MIS professor, so they focus a lot on this technology or technical issues in terms of implementation of data warehousing, in terms of the security of scalability of the data warehouse, how do you scale up, and in terms of security and the ethical issue, policy following, and so on and so forth. We need to sort of like browse through, skim through these terminology and not really sort of like spend too much time try to kind of make this become an obstacle of you learning this technology. The future of data warehouses, of course, go toward big data. So some of the ingenious professionals invent new terms. For example, they will use a terminology called data lake to make the data warehouse go beyond the structured data warehouse to into a much bigger scale. But it's actually not really meaning useful, I should say. You will very rarely hear people talk about data lake. People will start using a new terminology called the cloud database or the big data just become a more general terminology in that direction. And to process big data or data lake using the older terminology. And what is the most efficient way? And it is actually an important topic to discuss. We can, yes, there are actually two trends in the future of data warehouse, or when the textbook say future, is actually already nowadays. The book was written in 2016, and in 2020, we see a lot of solution in this new data warehouse, new big data era. One is bigger and faster cloud operation to accommodate the data size becoming bigger and bigger and bigger. And the other thing is actually more important, the future trend is artificial intelligence or AI has become the tool. Now, human being cannot be there 24 hours a day doing data analysis. So a lot of this data analytics has been done by artificial intelligence already. So a lot of tools that you'll be given to do a data analysis also have that artificial intelligence flavor. So as a human being, that how do we deal with the emerge of artificial intelligence become a interesting issue to study, and it is an area I do not have answer to you, what you should be learning, how do we deal with it. But it is an area you should be worried about because that's the people know how to utilize and work together with artificial intelligence will be the person has competitive advantage on the job market in the future. So with that saying, I'll leave this thinking to you to think about artificial intelligence will be the future of data analytics in at least from the descriptive analytic perspective. Business analytic or business intelligence or business or prescriptive, I'm sorry, descriptive analytics. All these are not so useful unless you have a methodology or platform to go with it. And when we say the platform, it is a process of selecting and presenting the metrics, right? Metrics what? Is the performance measurement in the organization. So the rest of the chapter talk about different uh, ideology, methodology used to select and derive those metrics in the organization to as the soul of your business analytic well, as a result of your business analytics. So the first one is called the business performance measurement. It is actually a methodology, a more complicated methodology than what your textbook has been presenting. But again, basically, it is a concept of how do you select the best KPI or user terminology called KPI, key performance indicator. And when you select the right performance indicator, you will monitor the data correctly and help the organization to grow correctly. And in management, you probably heard other professors say that what do you measure is what you get. And that measurement, what do you want to measure is important. Do you measure sales? Do you measure efficiency? Do you measure quality? So all these are different measurement. So business performance measurement is the process of selecting and monitoring those measurements or KPIs. And some people refer to the KPI as business performance measurement. In the process of performance measurement or business performance measurement is usually go through some sort of cycle. If you look at this type of cycle, you will see that it is very similar to many cycles you have learned from the school of college of business, including quality control cycle, include that system analysis project management cycle. So business performance management, the key to that business performance management, again, as I mentioned, is the selection and monitoring of KPI. If you select the right KPI and monitor that, analyze that API correctly, then you will get the organization result from the data analytics. And so the textbook tell you that there are certain criteria of how do you select these KPI. And the KPI selection is really a case by case situation. Different organizations have different needs, and so this will become more a project, worthwhile, sort of like a discussion. If you have any that business project you want to perform, this will be one interesting topic to talk about. Some of the KPI are leading KPI. Some of the KPI are lagging KPI. So the understanding the nature of your KPI is important. Now, without explaining too much in the summary, I would like to use one example, kind of joke. For those of you who are accounting major or you have friends who are accountant, a lot of time we are joking about in the business school says accountants are historian in business, which says that the data, the report they are generating are historical data. Those are the thing we, as a technology person, we call them as lagging indicators. So if you are a investor, stock investor, you probably will hear this a statement a lot. It says past performance does not indicate future performance. That is exactly what you are saying here. The company's past sales performance does not give you the true indication of the future performance, meaning that when you try to buy a stock, the past information or lagging information are only can be used as a reference. So the R's and the important thing, of course, is to selecting this leading indicator. So which indicator is a leading indicator now? That become $1 million, $1 trillion question. Anybody know that will be able to become a successful manager, investor. You buy stock, you know which indicator to look at. You'll be able to predict the stock market. So the leading indicator actually is discussed more later in the textbook in terms of predictive analytics. So knowing leading indicator, you can build predictive model already. But in a general sense, some of the indicator from our traditional understanding or common sense of business, you already have some sense. For example, internal operation, your internal efficiency, a lot of time will translate uh, into future profit. So internal efficiency, if you measure that internal efficiency, the future sales or profit, actually profit and sales are different, can be realized. So internal efficiency can be a leading indicator, right? And the profit will be the lagging indicator in organization performance. The second methodology or model that used to define how do you measure and use data for monitor organization is called a balance scorecard. The balance scorecard is actually a best-selling book in the late 1990s, and it was published in Harvard Business Review earlier in the 90s and become a book later on. And this model is basically telling you that there are a set of common measurement in organization that we try to measure to monitor the organization, monitor the enterprise. These measurement can be classified into four categories: financial performance, customer perspective, learning and growth perspective, and internal operation perspective. So you try to identify KPIs or indicator in each one of these categories and try to monitor your organization. You can build a very good monitoring system or descriptive analytics model, or sometimes we just simply call them a dashboard for your organization. So the concept of the terminology dashboard, business intelligence dashboard that you learn in chapter 2 and later in your future chapter is usually derived from this balanced scorecard model, because you are selecting different component of the measurement, try to represent the true performance of your organization. As a nowadays example of how do we use this balanced scorecard dashboard is looking at a company. For example, when we look at a very popular company nowadays called Tesla, right? So everybody know Tesla, Elon Musk. Tesla produce electric cars and rocket and some of the future driverless car and so on and so forth. And this company, if you look at their financial performance, they haven't make any money yet. They're losing money. They put a lot of investment. So if you only use the financial performance to measure this company, you cannot see the future of the company. So you have to look at the company in other perspective. How the market I'm looking at the left-hand side of the balance scorecard. If the market is favorable to the company, this company has future. Internal business process perspective, how does Tesla manage the company internally? Now, in just about a year and two ago, Tesla's stock price was at about $250, and this year, 2020, their stock price soared to $1,000 just a few days ago. And why the triple or quadruple of the stock price? And one of the reason is because in the 1 year or two ago that their business operation is very inefficient. Their California factory cannot produce the car fast enough to meet the demand. Customers have to wait like 3 months to 6 months to get their car. But just about earlier in 2019, Tesla had built a factory in Shanghai, China, and that particular factory actually has a more robust production capability that raised the internal operation of Tesla to a higher level. So their operation on the right-hand side of the balance scorecard become much better. And you look at the learning and growth perspective, Tesla is a knowledge-focused company. They invest a lot of in R&D, in the battery technology, in artificial intelligence. So it seems like the company is very good at three perspectives and is only weak in one perspective. So that is why people believe this company is a future star because major from your balance scorecard, you can easily see how this company perform. So if you're an investor or if you're a company manager, I recommend using this balance scorecard. Try to evaluate every organization operation you try to encounter. To me, is I use this method to investigate or to evaluate the my stock portfolio, and it served me very well. And I would not boast myself too much, but yeah, I performed very well on the stock market by selecting the right company, performing uh, short term a little bit worse in the financial perspective. But I look at other perspective of the company, and if that gives them an advantage, and I would buy low and try to realize the gain in the future. You might want to do the same thing as well. Hope you make more money. In the quality control world, that we have spin off a lot of methodology using data to do internal control. This include, say, for example, Six Sigma, and one of the terminology spin out of Six Sigma is called DMAIC, DMAIC, and that is actually describing the process of defining, measuring, analyzing, improving, and controlling the process. Six Sigma is a quality framework. It's the entire quality movement. If you recall your production and operation management course, is about process improvement and using the data collecting along the operation processing, you can control the organization very well. So the idea is using data to do the control. DMIC, DMIC. Different people pronounce this acronym differently, but bear with me. DMIC or DMIC is the terminology we use to describe Six Sigma management framework. And the Six Sigma also use the descriptive analytic a lot, using a dashboard a lot. And one a caveat of the terminology, if you recall that in your production operation management, Japanese quality management has used a method called the Kanban. So what is a Kanban? Kanban is actually a dashboard. It is a real-time report to monitor the operation, process operation in organization. So we know that at the end of chapter 3, we learned that the data warehousing and business intelligence, they are a OLAP analysis or PV chart analysis in steroid. And we have to use a framework to select the correct KPIs and measurement in order to use your data warehouse, in order to use your uh, descriptive analysis very well in monitor and improve organization performance. So that will be the conclusion of our chapter 3. I hope you learn some terminology and hopefully get some stock buying trick as well from my summary of this particular chapter. And I'll talk to you next time.